Okay, so for my project, I chose to do question 78 from section 3.2 on one-sided limits and continuity. So as you can see here, the first question is f of x equals x squared minus 4 over x plus 2. And then on the bottom of the piecewise function is k. And this is, we're solving for the value of k if f was going to be continuous from negative infinity to positive infinity. So the first thing what we have to do is try to simplify the top, because if we sub in 2 into it, then we will get 0 over 0, which is an indeterminate form. So the first thing that we did here was we simplified from x squared minus 4 to x minus 2, x plus 2. And then everything that we're left with is x minus 2. And then all we have to do is take the limit of x as it approaches 2. And we end up with negative 2 minus 2, which is equal to negative 4. And then as you can see here, it is, because k is already by itself, we don't have to do anything, and it just equals negative 4. Okay, for the next question, for number 79, we see f of x equals a times the square root of x plus 7, and on the bottom is 2x minus a. So we're solving for the value of a that will make f continuous at x equals 2. So the first thing what we're going to do here is take the limit from the left-hand side. So we end up with a times the square root of 2 plus 7, which simplifies into a times the square root of 9, which is equal to 3a. And then we have to, that's like the left-hand side, so now we take from the right-hand side the limit. So we sub in 2 into the bottom half of the piecewise function, and as you can see there, we get 2 times 2 minus a, which equals 4a. And then according to the third condition of continuity, we have to set both of them equal to 0. So as you can see on the right-hand side of the page, I did 3a equals 4 minus a, and then all you have to do is solve for a, and you end up with a plus 1. So in the end, the value of a that will make f continuous is 1. Okay, so for question 80, we see here that f of x equals negative x over a, and on the bottom of the function we see a times x plus 1 squared minus 4, and we're solving for the values of a that will make f continuous at negative 3. So the first thing we have to do is take the limit from the left-hand side. As you see there, I did it, and it came up to negative 3 over a. So that's all we have to do for that one for now. So for the second condition, we had to solve for the right hand, or we had to solve for x as it approaches 3 from the right-hand side. So what we did here was we plugged in negative 3 for into the bottom function. So we get a times negative 3 plus 1 squared minus 4. We solved that, and we got a equal a times negative 2 squared minus 4, and that came up to positive 4a minus 4. And then as you can see here on the right, we had to do the third condition for continuity, so we set them equal to each other, and when we solved that, it came up to a quadratic, and then we solved by factoring, and we got a equals 1/2 and a equals 3 over 2, which is equal to 1.5. So we can see here that at the values of a that are 1.5, and 1/2, that f will be continuous.